Tonight, you close your eyes. When you open them again, it's not tomorrow morning, it's 10 years later. Your body hasn't aged in any way that matters. You didn't feel a single day pass. No boredom, no hunger, no fear, just darkness and then light again. It sounds like science fiction, but something remarkably close to this already happens in nature. Every single year, all around us. So the question worth asking is simple. Could humans ever do the same thing? Can humans hibernate? The science of sleeping for years high in a mountain den, a bear settles into the dark. Its heartbeat slows to a fraction of its normal rhythm. Its body temperature drops. Its metabolism, the engine burning energy every second just to keep it alive, idles down to almost nothing. For months it will barely eat, barely move, barely burn any fuel at all. And when spring finally arrives, it wakes up, largely unharmed by the stillness of winter. Ground squirrels do something even more extreme, letting their body temperature drop close to freezing. Certain bats tuck themselves into caves, slipping into a similar deep, energy saving stillness for the better part of a season. Even some primates, our closest relatives in the animal kingdom, have been observed entering lighter versions of this state during especially harsh seasons, slowing their systems down just enough to conserve precious energy until conditions improve. Across the animal kingdom, this ability has evolved again and again, independently, in wildly different species. That alone tells scientists something important. Hibernation isn't a rare biological accident. It's a solution nature has found and refound many times over. Hibernation isn't rare in nature. It's one of evolution's most elegant survival tools, a way to simply wait out the hardest months of the year. And yet, as far as science has ever confirmed, no human being has ever done this. Our bodies work differently. We depend on keeping a remarkably stable internal temperature day and night, season after season, with very little tolerance for change. Drop a human body temperature by just a few degrees for too long, and organs begin to struggle. Drop it further, and the risks multiply quickly. Where a hibernating bear's biology is built to slow down safely, ours simply isn't wired that way. Not yet, at least. But that hasn't stopped scientists from trying to get close. Researchers today are exploring something called induced torpor, a temporary, carefully controlled state where a patient's metabolism is deliberately slowed under medical supervision for a limited period of time. The idea isn't science fiction. It's already being studied as a way to help patients survive severe trauma, complex surgeries, or moments when the body isn't getting enough oxygen. Slow the body down enough, even briefly, and you may buy crucial extra time. Time for surgeons to operate. Time for damaged tissue to hold on just a little longer. This isn't full hibernation. It's something much smaller, much more controlled, but it's a real active area of modern medical research. Now imagine taking that same idea and pointing it toward the stars. One of the biggest obstacles to sending humans to Mars or anywhere deeper into space isn't fuel or engineering or distance, it's us. Human bodies weren't built to survive months or years sealed inside a small vessel, floating through the emptiness between planets. Muscles atrophy without gravity. Bone density drops. Isolation and confinement take a serious toll on the mind over such long stretches of time. A trip to Mars, even under optimistic estimates, could take the better part of 2 years there and back. That's 2 years of cramped quarters, recycled air, limited contact with home, and a body slowly wearing down in an environment it never evolved for. But what if astronauts didn't have to experience most of that journey awake at all? A hibernation-like state could, in theory, drastically cut down on the food, water, and oxygen a spacecraft needs to carry. It could reduce the psychological burden of years spent in a cramped metal box drifting through the dark. Space agencies and researchers have taken this idea seriously enough to actively study it, precisely because the payoff, if it works, could be enormous. But here's the reality: we are still very far from making this safe. Muscles waste away rapidly without movement, even over weeks, let alone years. Bones lose density at an alarming rate when the body goes still for too long. Blood is more prone to dangerous clotting when circulation slows. And perhaps most concerning of all, we still don't fully understand what long-term stillness would do to the human brain and other organs over extended periods. Slowing a heartbeat down is in some ways the easy part. Doing it safely, for months or years, without permanent damage, that's the real unsolved puzzle. Even so, researchers haven't given up. Scientists are studying new drug compounds, advanced cooling techniques, and biological mechanisms borrowed directly from hibernating animals, hoping to unlock some of the same protective processes evolution already perfected. Progress in laboratories and controlled medical settings has been genuinely encouraging, but true, safe, long-duration human hibernation has not yet been achieved, not even close, by most expert estimates. Getting there will likely require breakthroughs we haven't made yet, in medicine, in biology, and in our basic understanding of how the human body actually works under extreme stillness. So where does that leave us? Nature has already proven that hibernation works beautifully, efficiently, safely for creatures built for it. Bears do it every winter. Ground squirrels do it every year. It's not some biological impossibility. The real uncertainty isn't whether hibernation can exist. It's whether human biology can ever be safely nudged into doing something it was never originally designed to do. Remember the idea we started with? Closing your eyes tonight and opening them a decade later? We're not there yet. Not even close. But for the first time in history, serious scientists in serious laboratories are asking the question with a straight face. If we ever do solve this puzzle, the implications reach far beyond curiosity. Emergency medicine could change. Deep space exploration could open up in ways currently limited only to fiction. Humanity's relationship with time itself could shift in ways we've barely begun to imagine. If one day we truly learn to sleep through years without losing ourselves to the passage of time, how would that change what it means to be human at all? If this made you look at sleep and time a little differently, that's exactly the kind of question Secret Horizon loves digging into. Every episode, we take one strange, real scientific idea and follow it all the way to the edge of what we currently know. Subscribe so you don't miss where the research goes next. And if you have a what if question of your own, science, history, or something in between, leave it in the comments below. We genuinely read every one, and some of them become future episodes. This documentary explores current scientific research related to hibernation, induced torpor, and potential applications in medicine and space exploration. It is intended for educational purposes and distinguishes established biological facts from ongoing experimental research and future possibilities. Human hibernation, in the way described toward the end of this documentary, remains a scientific hypothesis and has not yet been achieved. Our goal is to present an honest picture of what current research has shown and what remains uncertain.